let's solve this limit here. Limit as x approaches 0, secant x minus 1 all over x squared. So whenever you get a limit question, the first thing you want to do is plug whatever the value x is approaching to into x first and see if you can get the answer. If you get the answer, you're done. If you don't get the answer, you have to do more work to get to the answer. So let's try this. So we will put that in secant 0 minus 1 all over 0 squared. Now, secant 0 is the same as 1 over cosine 0. And cosine 0 is 1. So this is 1 over 1, which is 1. Okay, so that is equal to 1 here. 1 minus 1 all over 0 squared is 0. Now 1 minus 1 is 0. So 0 over 0. That's indeterminate form. That's not the answer you want. So you have to do more work to get to the answer. Okay, so here. We will solve this in two ways. So let's look at the first way, method 1. Now in method 1, we were just trying to find out how we can get to the answer. So look at the original limit here. Limit as x approaches 0, secant x minus 1 all divided by x squared. Okay, so what do we do? Look at this, secant x. We want to rewrite secant x as 1 over cosine x first. So that's limit as x approaches 0. One over cosine x minus 1 divided by x squared. Okay, now since you have a fraction here, you want to find a common denominator here and then group the fraction together. And we know that 1 over 1 should be cosine x over cosine x. Now all over x squared. Now we can group this together. Limit as x approaches 0, 1 minus cosine x divided by now cosine x, and this all divided by x squared. And of course, 1 minus cosine x divided by cosine x and then divided by x squared. You can just move the cosine x down here. So that will become cosine x times x squared, like that. Okay, so what do we do next? Now we know that what we can do is we can separate this into 1 over cosine x times 1 minus cosine x all divided by x squared. So we can do this. Limit as x approaches 0, 1 over cosine x times 1 minus cosine x all divided by x squared, like that. Okay, now we can distribute the limit here according to the limit property. So we can write this as limit as x approaches 0, 1 over cosine x times limit as x approaches 0, 1 minus cosine x all divided by x squared. Okay, so we know that if we put 0 into x here, we have cosine 0 equals to 1, so 1 over 1 is 1. So this limit is okay. How about this one here? If you put 0 into x here, you get 1 minus 1 divided by 0 squared. So you still get 0 over 0. So this is not okay yet. So what do? Okay, now looking at this limit here, we do see that this is 1 minus cosine x. And we know that we can convert this into sine x or sine square x because we have an x squared here. Because we know that this limit here is equal to 1. If I can just multiply this fraction by its conjugate, which is 1 plus cosine x, I can turn this into 1 minus cosine square x. And then 1 minus cosine square x is just sine square x. Then I can have sine square x over x squared here, right? Then I can separate this into 2 of this. Then I have a limit equal to 1. Okay, let's do this. Now, times 1 plus cosine x over 1 plus cosine x. We know that this fraction here is equal to 1. That means I've not changed anything. Okay, now we'll keep this the same. Times limit as x approaches 0. Now, the top here becomes 1 minus cosine square x. Divided by the bottom becomes x squared times 1 plus cosine x. Like that. Now, we know that 1 minus cosine square x is just sine square x. So we have this. Sine square x divided by x squared times 1 plus cosine x. Like that. Now, I will separate this fraction into this way. Sine square x divided by x squared times 1 over 1 plus cosine x. Like that. Now, again, I can distribute the limit here to this term too, right? According to the limit property. So, here. Now, we do know that sine square x over x squared can be written as sine x over x times sine x over x. And then, of course, okay, let me write this one down first. Limit as x approaches 0, 1 over 1 plus cosine x. Okay, now, this I can distribute the limit property. So limit as x approaches 0, 1 over cosine x times limit as x approaches 0, sine x over x times limit as x approaches 0, sine x over x. Like that. Times this limit. Okay, like this. Okay, so what's that equal to? We can put 0 into x here. So 1 over cosine 0, right? Times, we know that this limit here is equal to 1, right? So that's 1 times this is 1 times, what's this? 1 over, now 1 plus cosine 0, right? We know that cosine 0 is equal to 1. So this is 1 over 1, which is 1 times 1 times 1 times, what's this? Cosine 0 is 1. 1 plus 1 is 2. So this is 1 over 2. 1 times 1 times 1 times 1 over 2 is 1 over 2. Okay, so that's the answer to this limit. Here. Now, let's look at method 2. Now we know that at the beginning, when we directly put 0 into x here, we get 0 over 0. That means we can use the L'Hopital's rule. Okay, so here, method number 2. And we'll use the L'Hopital's rule. Now, the original limit was limit as x approaches 0, secant x minus 1 divided by x squared. Okay, now, to use the L'Hopital's rule, we have to take the derivative of the numerator and the derivative of the denominator. So it will look like this. Derivative of secant x minus 1 divided by derivative of x squared. Okay. Now here, we know that derivative of 1 or negative 1 is just 0, right? So what's the derivative of secant x? Here, let's look at it like this. Derivative of secant x. That's the same as derivative of 1 over cosine x. Okay, since this is a quotient, right, of two functions, we have to use the quotient rule. So what is that equal to? That will be the bottom function, cosine x, times the derivative of the first function, which is 0, right? Derivative of 1 is 0, minus the first function, which is 1, times the derivative of the bottom function, which is negative sine x here. Okay, all over the bottom function squared, which is cosine x squared. So cosine x squared. So what is that equal to? 0 times cosine x is 0, right? Now minus minus become plus. 1 times sine x is sine x. Divided by cosine square x. And that's equal to sine x over cosine square x. What's that equal to? We can separate this. That is equal to sine x. Okay, let's write this first. 1 over cosine x times sine x over cosine x. I can write this, right? Then this is equal to secant x times this is equal to tangent x. So that's the derivative of secant x. Okay. Limit as x approaches 0. That's equal to secant x tangent x divided by derivative of x squared is 2x. Okay, now let's put 0 into x here to see what we get. If we put secant 0 times tangent 0 divided by 2 times 0. Now secant 0 is basically 1 over cosine 0, which is 1, right? But tangent 0 is 0. 0 times 1 is 0. 0 times 2 is 0. We still get 0 over 0. So that's not the answer we want. That means what we have to do is we have to apply the L'Hopital's rule again on this limit. That means we have to do this. Limit as x approaches 0, the derivative of secant x tangent x divided by the derivative of 2x. Okay, now let's look at the derivative of secant x tangent x first. Here. Since this is a product of two functions, so we have to use the product rule. So that would be the first function, right? Prime, secant x prime, tangent x plus secant x times tangent x prime. And we know that the derivative of secant x is here. We already did this. Secant x, tangent x. So we have secant x, tangent x times tangent x plus secant x times the derivative of tangent x. Now, what's the derivative of tangent x? Here, let's look at it here. That's the same as derivative of sine x over cosine x. Since it's a quotient of two functions, we'll use the quotient rule again, right? And that's equal to the bottom function, cosine x, times the derivative of the first function, which is sine x, and the derivative of sine x is cosine x, minus the first function, which is sine x, times the derivative of the bottom function. The derivative of cosine x is negative sine x. All divided by the bottom function square, which is cosine x squared. Now, cosine x times cosine x, cosine square x. Minus, minus become plus. Now, sine x times sine x is sine square x. All divided by, this is cosine square x. Here, cosine square x plus sine square x is 1. So this is 1 over cosine square x, which is also equal to secant square x. So that's the derivative of tangent x. Now here, times secant square x. Now this will be secant x tangent square x plus secant cube x. Okay, so here, that is equal to limit as x approaches 0, secant x tangent square x plus secant cube x. Here. All divided by derivative of 2x is 2. Okay, now let's put 0 into x here and see how it looks like. So that is secant x. So secant x is 1 over cosine of x times tangent square x. Okay. Since I'm not putting the 0 in here yet, so I have to still write the limit. Plus secant cube x, which is 1 over cosine cube x. All divided by 2. Then we can put the 0 in here now. 1 over cosine 0, tangent square 0, plus 1 over cosine cube 0, all divided by 2. Let's see what we get here. Cosine 0 is 1. 1 over 1 is 1. But tangent square 0 is 0. So that's 0. Plus cosine 0 is 1. So cosine cube 0 is 1. 1 over 1 is 1. over 2. Now 0 plus 1 is 1. That is 1 over 2. Okay, so this answer is the same as the answer we get in the first method. 1 over 2. So the answer to this limit is 1 over 2. Hope you enjoyed this video. Don't forget to subscribe to my channel. Thank you.